So the same option is available for Zoom also, but only the host can take the
Yeah, so
attendance.
where I have to do that? Tell me.
Sir, in the meeting details, you would find an option report.
The meeting option, I will find an option report.
Yeah, like usage report, and in that we have to just click.
Huh? Say again,
So
please.
when you go through the to the report,
Report is not coming better. Mute, start video, security, participants, new share, pause share, whiteboard, remote control. And in more, there is record in this computer, record to the cloud, meeting info, disable annotation for others, hide the name of annotators, hide floating meeting control, share computer sound, optimize screening. No, it's not coming.
No, sir. Actually, you won't get that option here. After the class has completed, you have to sign on your Zoom account separately in the web browser.
Okay. And
And
their
only
attendance will be available. Is it what you're
yes,
saying?
yes, sir. There's a date range.
Okay.
You have to put that date range, and you'll get the participants list there.
Okay, fine. So let's move on to the idea that we have to discuss. I'll see to that in this class. If it is not possible, I'll ask you again. And I think you guys will help me for that. So you can see I have drawn 4 blocks. One is keyboard, another is hard disk, another is printer, another is processor. And I mean, you guys actually, and of course, you can have a screen as well. Sorry. So how to connect all these things? That's the question that we are looking at. So can you suggest me something? So processor should have a wire with keyboard, a wire with hard disk, a wire with screen, a wire with printer, something of this kind. Then this, and then this, and then maybe hard disk can also have some connection with the. Okay, let's keep it now this much only, right? You're getting what I'm trying to say? Because processor has to communicate with all these devices, it should actually be having wires to all that, right?
Yes.
Getting my point? But then this is quite inefficient and clumsy structure. Why this is inefficient and clumsy? Suggest me.
Sir, because a particular one device should be connected to each other devices, and so there will be.
That's one thing. Moreover, when processor is not talking to keyboard, for example, your this at particular instant, this processor is not talking to keyboard sometime. It will not be talking always, or processor is not talking to printer whenever it is not talking. When it is talking to hard disk, these lines are actually not being used, right? Is it okay?
Yes, sir.
And then you will be having number of wires where you have to make the connections. So I have shown only very small number of peripherals. That too I am considering the case when peripherals are actually not talking to each other. So in that case, it seems little easier. But when you are talking about the case when peripherals are talking to each other, it becomes more complicated. So then what should we do? Tell me. What should we do in that case? So suppose these are the houses, and this is some place that we call as the office. One possibility is I can draw the roads from all the houses. What may be other possibility?
Joining into a
Connect the
single
three
road.
houses and then
Huh?
One main
join it.
road and all
So
houses are
draw
connected.
a main road
Yeah.
and connect it with the office and connect with all the houses. In computer, main road is termed as, you must be knowing this,
Bus address, bus memory,
not bus address, it is simply called bus.
bus. Yeah.
So when we are shifting from this thing to this thing, what is actually happening? This is one thing that we are simplifying the system, that's one. But there are certain complications to that. What are those complications?
Only signal from one unit can come at a single time.
Yeah, so in first case, everybody can communicate to the office whenever they wish. But now you have to make sure that if you are going on the road should be empty. If you are moving on the road without making this sure, what is going to happen? You will be actually colliding with someone. So there is some kind of access control system should be kept in place. Right? You're getting my point? Yes or no?
Yes, sir.
So there should be some kind of access control system should be in place that will make sure that the communication of two devices are actually not colliding with each other. I'm just drawing possibilities. So bus will look something like this. So few devices may be talking in both the directions. Few devices may be talking in one direction only. But the point is whenever one is communicating in a certain area, in that area others should not be communicating. So to have this kind of facility, these devices use something called buffer register. What this buffer register do? So whenever a device has to give some data to so suppose it's a input device, let's say keyboard. So whenever keyboard has a data, keyboard will keep this data in this buffer register. There will be a buffer register sitting. And whenever bus is available, this buffer register will push the data to the bus. Similarly, suppose it's a screen. Whenever data is coming for the screen, and let's say screen system is not free, this will kept in buffer register. When screen system is free, it will take data from the buffer register, right? Is it okay?
Yes, sir.
And there are possibilities when a fast device is communicating with a slow device. So this is probably sending data in a very fast manner, and this is not able to consume that data that fast. So here also buffer registers come into picture, and that actually solves some of the problem. So when this slow device cannot consume the data, this will store the data in buffer register, and that way, I mean, bus will be transmitting the data, and this will be storing the data in buffer register, and eventually when it will be able to consume, it will consume. So these are few very basic things that we are talking about bus. Bus is a very efficient, flexible kind of system that is used for the communication within the devices of computer quite largely. We'll discuss about bus operations up to on a great detail. This is I you just as an introduction part of the right. You're getting my point? Any
Yes, sir.
immediate confusion about bus? Any immediate confusion about bus? No?
No, sir.
No, sir.
What are the starting and ending point of this bus?
Yeah, that's a very good question. What are the starting and ending point of the bus? So actually bus does not have a starting and ending point. So bus is a common pathway that connects all the devices together. So whenever two devices wants to communicate, they actually inquire other device and push the data. So as such, there is no ending and starting point in there. Of course, physically you can see that it is ending somewhere and it is starting somewhere, but actually that is not the ending or starting point, right? Is it okay?
Yes, sir.
Fine. So now let's talk about software. SF stands for software. I hope you understand that in a computer system. So there are two kind of softwares generally. Can you name those? What are the two kind of softwares in a computer generally?
Application
Come on, you
utilities.
know that, right? Yeah, tell me.
Application and utility.
One is application, right? Another is
Utility software.
come up with a better name.
System software.
Yeah, exactly. So the term that we use for this is system software, application software and system software. So we'll start with what a system software actually does, and then we'll see what application software does, and then we'll discuss one of the most prominent system softwares. What is that? What is the most prominent system software?
Operating system.
Operating system, exactly. So we'll talk a bit about operating system, and another second most prominent our system software. What is that?
Drives.
Say again, please.
Driver softwares.
Utility
No,
software.
no, no. The second most prominent, or I can also call it first, is text editor. So without text editor, you cannot do anything. So that's why I'm calling it as one of the most prominent system softwares. Right. So if we'll discuss the function of system software, very first job is receive and understand commands. What does it mean? So you need certain utilities, and those utilities we call commands. So you have certain commands in place that user can understand and give it to you. So you have to have some system software part that will be used in utilities, and user can ask to do that, right? Is it okay? Is it fine? Huh?
Yes, sir.
You guys are not speaking at all. Yes or no, nothing. And then editing and editing, as we already said, editing application program. And managing storage. And can you suggest me something more? Tell me. आपने कमांड्स से आपने एप्लीकेशन प्रोग्राम को एडिट कर लिया, आपने स्टोरेज को मैनेज कर लिया, अभी और क्या होगा?
Scheduling commands according to their priorities.
जहां पर हमने कहा, अच्छा ओके, यू कैन से दैट एज वेल, ओके, सॉरी, scheduling and what else? Running applications.
So have you written?
You are not able to look at?
No, sir.
No, sir.
Red arrow.
Okay. Oh, sorry. Whiteboard got changed. Sorry. Scheduling. Thanks for pointing out. Running programs, or I should say running application programs. So I'm calling those apps because apps also in a kind of application program, and controlling IO units. IO, and of course, yeah. So these are the functions for a system program, system software, right? So
Yes.
you can say that system software is actually a coordinator kind of thing that coordinates all the activities in computer. Whereas application programs have a very specific kind of job. So for example, you have something like MATLAB. Have you heard about this?
Yes, sir.
So you use it for some scientific purposes. Then you have something like MS Word, or you can say MS Office. So some kind of very specific job, right? Is it okay?
Yes.
So here there is one point that you should, actually observe that MS Word is not a system software, whereas I have earlier written that text editor is a system software. So MS Word is what then? Is it not a text editor?
It's actually a text editor.
Huh?
Sir, it's a third-party software.
No, it is third party or first party. That's not the question. The question is whether it's a system software or not.
So it is application software.
Why? I have already said that text editor is a system software.
So it's not an inbuilt software. That's
Huh?
so it is not inbuilt software.
Okay,
So
but
we
then,
can stop it.
yeah. So it is not merely a text editor, it is actually a text processing, or you can say word processing software. So text editor is something simple where you can put in some text and that can be given to the system. So of course it can be used as a text editor, but it is not a simple text editor. It is a word processing or text processing thing, right? Is it okay?
Yes, sir.
Yes, sir.
So I hope by now you would have understood the difference and examples of this thing. System software and application program or application software. Is it able to, are you able to understand this?
Yes, sir.
Yes, sir.
Okay, now let's talk about let's talk about OS a bit. Although some of you would have read a course on OS. कंप्यूटर साइंस वाले लोगों ने OS पढ़ लिया है क्या अभी?
No, sir.
इसी वालों ने तो नहीं ही पढ़ा होगा for sure, या पढ़ा है?
So, some people have studied, those who took it as an elective.
Okay. तो जिन्होंने लिया है उनको तो शायद ये पता होगा, फिर भी मैं कुछ थोड़ा सा डिस्कशन OS के बारे में करूंगा. तो how a OS actually facilitates running a application software. This we want to understand. तो सबसे पहले हम स्टेप्स देख लेते हैं इसमें कि कौन कौन से स्टेप्स इसमें लगने वाले हैं. तो सबसे पहला स्टेप क्या होता है? So suppose there is a application program. Maybe you need to compile this. ठीक, हो सकता है कंपाइल करके रखा होगा तो भी हार्ड डिस्क में रखा होगा, और नहीं करके रखा होगा तो यू हैव टू कंपाइल इट, एंड द कंपाइल्ड वर्जन ऑफ दिस हैव टू बी स्टोर्ड इन हार्ड डिस्क, राइट? इज इट ओके?
Yes, sir.
समझ में आ रहा है आप लोगों को मैं क्या कह रहा हूं?
Yes, sir.
आज बहुत कम आवाज आ रही है, क्या बात है? You guys are not able to understand this? हाँ?
आ रहा है सर समझ.
नहीं, मुझे ऐसा क्यों लग रहा है?
माइक अनम्यूट करके यस सर बोलना, फिर माइक वो करना पड़ता है.
Okay. So first of all, you take an application program. You convert it to executables using a compiler. Executables, you understand, right? And these executables are stored in hard disk. When these executables are called, I'm saying executables, that means I'm talking about Microsoft Windows, not general. Call exe. So जब आप exe को call करेंगे तो processor will go to hard disk and it will call some exe files. These exe files will be actually processed. Maybe needing some kind of input, and then they'll be generating some kind of output, and that will be stored at hard disk or may go to printer. Right? इतना सब आप करते हैं इसमें? ऐसे ही होता है? हाँ?
Yes, sir.
Is it okay?
Yes, sir.
थोड़ा अनम्यूट करने का कष्ट उठाना पड़ेगा, लेकिन बोलेंगे तो मेरे लिए थोड़ा कंफर्टेबल होगा. Sorry, line is too bad. Now let's see on timeline. So let's call this time as T0, and then something we'll call it T1, then we'll call it T2, then we'll call T3, then we'll call T4, and then we'll call T5. And what all actors are there? So one thing is program. Another actor is OS routines. And then disk. And then printer. So first let me tell you what do I mean by OS routines. So हमने अभी ये जो पीछे बहुत सारे काम लिखे, इसमें से बहुत कुछ काम है जो जैसे एप्लीकेशन प्रोग्राम को आपने एग्जीक्यूट किया तो कंपाइलर उसको एग्जीक्यूट करने में यूज हुआ, फिर आपने उसको स्टोर किया तो इसको स्टोर करने के लिए कुछ काम करना पड़ा होगा जो किसी ना किसी प्रोग्राम ने किया होगा, वो एक छोटा सा सब रूटीन या रूटीन होगा, उसको ओएस रूटीन कह रहे हैं। फिर आपने एग्जीक्यूटेबल को कॉल करने के लिए, कॉल होने के बाद एग्जीक्यूटेबल विल एग्जीक्यूट ऑन इट्स ओन, बट वो एग्जीक्यूटेबल को कॉल करने के लिए कुछ एक सब रूटीन की जरूरत पड़ी होगी। तो इस तरह के छोटे छोटे यूटिलिटीज हैं, और कई बार बड़े भी, साइज वाइज वो बड़े भी होते हैं कई बार ऑपरेटिंग सिस्टम में, उन सबको हम बोलते हैं ओएस रूटीन्स और ओएस यूटिलिटीज, राइट? जैसे if you want to store something, so you need a routine, that is OS routine, so that will be used in storing it somewhere, right? Is it okay? So yeah, so first of all at T0 कोई छोटा सा एक, इसका कलर चेंज कर देता हूं मैं, तो लेट्स से आई विल टेक दिस कलर। एक छोटा सा ओएस रूटीन चला होगा एंड उसने डिस्क पे जाके कुछ स्टोर किया होगा, फिर एक छोटा सा ओएस रूटीन चला होगा और उसने फिर कुछ प्रोग्राम के साथ मैनिपुलेशन किया होगा। So I mean, from this to this, from this to this, and this to this. These all are time slices. यानी टाइम में हम ये बात कर रहे हैं। उसके बाद फिर ये कुछ एग्जीक्यूशन के बाद फिर एक छोटा सा ओएस रूटीन आया होगा। इनफैक्ट ओएस रूटीन के लिए मुझे कोई और कलर यूज करना चाहिए शायद। Let me use a different color for this. Perfect. Let's redraw everything again. I'm just going to explain what I'm doing. So this is the way that time is being consumed. कुछ कह रहा है क्या? यहाँ पर कुछ मैं लगाना भूल गया, तो यहाँ पर भी कुछ लगा लीजिए। So this is the way it is happening. First, OS routine is executing. It is going to disk to call something from disk like this, and then that thing will be actually transferred, and a program will be executed, and there again there will be a OS routine, and then there will be another OS routine that will be actually storing to disk something to disk, and then some program will be taking output. And final output will be printed in form of printer, right? You're getting this point? So this way it is happening. The important point that I want to make here is there are OS subroutines that are coming in every place. So actually everything and anything is going to happen with the help of these small utilities. Though these utilities are small, but without these utilities, it will be difficult to get something done. Are you getting this point?
Yes, sir.
So the point is here, the execution control goes back and forth between application programs and OS subroutines. So this is actually what our operating system does. अगर मैं पूरे प्रोग्राम का एग्जीक्यूशन टाइम निकालना चाहूं इसमें, so this will be the execution time of complete program, that is T5 minus T0, right? Is it okay?
Yes, sir.
Yes, sir.
अब यहाँ इंपॉर्टेंट बात ये है कि ये वाला जो टाइम है इसमें मेरा प्रोसेसर क्या कर रहा है। बाकी टाइम में तो प्रोसेसर कुछ ना कुछ कर रहा है, जब डिस्क से डेटा ले रहे हैं तब भी प्रोसेसर डिस्क को रीड करने का काम कर रहा है। ओएस रूटीन तो ऑफ कोर्स प्रोसेसर में ही हो रहे हैं, प्रोग्राम भी प्रोसेसर में एग्जीक्यूट हो रहा है, यहाँ भी ये प्रोग्राम में प्रोसेसर में एग्जीक्यूट हो रहा है। यहाँ वाले ड्यूरेशन में मेरा प्रोसेसर क्या कर रहा है? कुछ नहीं कर रहा है या कुछ कर रहा है? हाँ
सर वो एक एड्रेस पे जो भी हमारा आउटपुट डिवाइस है वहां पे भेज रहा होगा।
हाँ, बट प्रिंटर विल टेक सम टाइम। अभी तो प्रिंटर्स बहुत फास्ट हो गए हैं, बट अर्लियर डॉक मैट्रिक्स प्रिंटर या ये प्रिंटर्स तो बहुत ज्यादा टाइम लेते थे। So that time processor is doing nothing, but processor can do something. So these kind of small gaps are available in all the executions, all the program executions. So this way, this time can be utilized using OS. And when we utilize this time, in that way we do multiple concurrent executions. And this multiple concurrent execution is termed as what? Tell me.
Multitasking.
Multitasking, exactly. Multi-programming or multitasking. So operating system not only facilitates you in terms of executing something, but it also helps you in getting things multitasking or multi-programming. So it is making your system more efficient. Any confusion in this by now?
No, sir.
Sure?
No, sir.
It is very difficult to see your faces, and I mean, I cannot see your faces, so it is very difficult to understand whether you are able to appreciate these things or not. Or most of you are not appreciating anything. I am just hoping that you are appreciating.
Sir, speed of our system mostly depends on OS routines.
You cannot say this. I'm just going to talk about speed, or you can say performance of the system. So speed of the system actually does not depend on OS routine. So OS routine is doing only one thing. OS routine is actually managing whatsoever resources are available and trying to use more efficiently. Yeah, if you want to say this, that if your OS routines are written inefficiently, your system speed will go down. Yeah, that is right. And efficiently written OS routines will make system more efficient. Yeah, that is right. But actually, with a certain level of efficiency, there are lot many things that will actually decide about the speed of the system. And we are going to talk about that. Right?
Okay, sir.
Does this answer your question?
Yes, sir.
Okay. Yeah. So now we'll talk about performance. So on what things the performance is actually dependent on. We have just taken an overview what our computer consists of, how operating system actually makes the system run, or I mean in general how system softwares make the system run. Now we have to understand the ways by which the efficiency or the performance or the speed of computer system is determined, right? Is it okay? So first thing is actually, where is my pen? Yeah, this is my pen. First thing is actually, okay, so make your system efficient. What is the first thing that you require? Can you tell me? This is my memory. And this is my processor. So what is the first thing that is required for this processor to give a better performance? Can you suggest me something?
Speed.
Speed of what?
Number of operations per second speed.
But to execute these operations sufficiently, you require the availability of the data. So program has to execute over some data, right? Whether it is a program itself or it is the number, it has to get the data, right?
Yes, sir.
So either data is coming from some input device or it is coming from a memory. From input device, because a human is mostly sitting at that end, you cannot do much. But you can do certainly with memory. So here what is happening? Data is coming all the way from memory through bus. And every time you need some data, you need to go to memory and memory will give the data. Right? Is it not? Is it okay?
Yes, sir.
So then a better idea could be you put a small memory SM here, and whenever required, you keep the data from this guy, and when you are done with it, you push in the data back here. Is it okay? Is it okay?
Yes.
Yes, sir.
No, it is not okay. If it is the case, then why not keep the complete memory here along with processor and just delete this? Why not? Why not do we should do this? Huh? Is this a right design? Is this a
Because when
right?
process,
Huh?
maybe that because when processor will not be working, then then we will not be able to store the data in the memory. That's why.
No, but then we'll not requiring memory. You'll store everything in processor itself.
So because building memory in the processor itself is expensive, as told earlier.
Yeah, so that is one reason. If you are building memory in processor, it is actually way expensive than making a separate memory. And second, if you are making memory in processor itself, it is going to be more complicated as well. So it will not be a good idea to do it like this. Rather, the better idea will be.
Sir, one more thing, we will not be able to expand the memory size. It will
Pardon?
be remain fixed. if it is inbuilt into the processor itself.
That is actually not the point, because even the outside memory size is fixed up with some limit, right?
Yes, sir.
So if you can make this size there, you can make the size in processor as well. So that is not the valid point. How that size is determined, I'll discuss about that. But the point is, if size can be there, size can be here itself. So that's why we put something here that we call cache memory and a processor along with processor. Now the point is what to keep in this cache memory. क्योंकि अगर कैश मेमोरी से काम चलता है हमारा तो फिर हम मेमोरी क्यों रखते हैं?
Sir, we could keep like those data which we need at the moment to do
But
the
how do
task.
we know that? अगर हमको ये पता ही है कि हमको कौन सा डेटा चाहिए तो उस डेटा के होने का कोई मतलब ही नहीं है.
Sir, only the
Sir,
crucial.
Sir, frequently used data.
Frequently used data है तो बाकी डेटा यूज का नहीं है क्या?
Yes, sir.
Sir, the
So
thing
there
is
is
that
something called locality of reference. This is a principle. किसी ने सुना है इसके बारे में? Locality of reference. ये आइडिया किसी ने सुना है क्या पहले? So locality of reference is a very simple principle that actually gives the reason for cache memory to exist is only this, that whenever you need, whenever you are using some thing in the processor, most of the things that you will be needing will be actually closer to what you are using. यानी जिस लोकेलिटी का मेमोरी में आप डेटा यूज कर रहे हैं उसी लोकेलिटी का डेटा आपको सबसे ज्यादा जरूरत पड़ेगी और उसी तरह के डेटा की ज्यादा जरूरत पड़ेगी. ये एक एजम्पशन है और इस एजम्पशन के फेवर में बहुत सारा स्टडी है. उस बेसिस पे हम कैश मेमोरी रखते हैं. लेकिन जब हमको वो कैश में नहीं मिलता है तो वी गो इनटू मेमोरी एंड ब्रिंग इट बैक टू कैश एंड देन गिव इट टू प्रोग्राम प्रोसेसर. राइट
सर?
हाँ,
समझ में नहीं आया, एक बार फिर से थोड़ा एक्सप्लेन करें.
लोकेलिटी ऑफ रेफरेंस एक एजम्पशन है जो ये कहता है कि मेमोरी में जो डेटा आप यूज कर रहे हैं, तो जैसे मान लीजिए अगर मेमोरी में आप इस मोहल्ले का डेटा यूज कर रहे हैं तो आपको जिस डेटा की जरूरत इसको एग्जीक्यूट करने में पड़ने वाली है वो इस मोहल्ले का ज्यादा होगा. मोहल्ला माने लोकेलिटी. You getting my point?
ओके, ठीक.
आप ये कह सकते हैं कि ऐसा क्यों है, इसके बारे में हम बात करेंगे ऐसा क्यों है, बट अभी इतना मान लीजिए कि ऐसा है. ठीक है? Does it make sense? And this assumption gives you a reason जिसकी वजह से आप कैश रख पाते हैं. लेकिन ऐसा नहीं होता कि कैश रख लिया तो हमेशा कैश से ही काम चल जाएगा. कैश से जब काम चल जाता है तब हमारी टाइम सेविंग हो जाती है. जब कैश से काम नहीं चलता तो फिर मेमोरी से डेटा लेके आते हैं, उसे कैश में रखते हैं और फिर प्रोग्राम को प्रोसेसर को देते हैं. सो देयर आर टाइम्स, उसके लिए एक टर्म यूज करते हैं हम उसे हिट रेशियो, कि कितनी बार ये ठीक से एग्जीक्यूट हुआ, कितनी बार ये ठीक से एग्जीक्यूट नहीं. ठीक है? Is it okay? Is it okay?
Sir, I have a doubt.
हाँ.
सर जब हम कैश में डेटा रखते हैं उससे हमारी स्पीड बढ़ जाती है, तो सर हम पूरी को कैश में क्यों नहीं रख लेते जो हम मेमोरी से लेके वापस कैश में आते हैं? सर मान लो कि एक से चल रहा हो, भाई हमने कैश में रखा बस, तो अगर हम 2-3 का रख पाए तो हमारी ज्यादा स्पीड हो जाएगी ना.
लेकिन फिर कैश बड़ी हो जाएगी और उस कैश एक कीमत है. तो आप ज्यादा कैश बड़ी अगर अफोर्ड कर सकते हैं तो आप ज्यादा रख लीजिए.
सर बट अभी भी तो बहुत कम होती है, 6 MB की होती है, 6 MB और बहुत कम होती है.
हाँ, तो अगर आप ज्यादा महंगे प्रोसेसर लेंगे तो उनमें कैश बड़ी होगी.
ओके सर.
I mean, you are engineer, so you always optimize with price, right?
Right, sir.
आप कभी ऐसे नहीं करते कि कितना भी पैसा लग जाए, ये साइंटिस्ट कर सकते हैं, इंजीनियर्स कैन नॉट अफोर्ड टू डू सो। या प्लीज, समबडी एल्स इज आस्किंग समथिंग।
या सर, ये क्वेश्चन था कि सर वो जो लोकेलिटी ऑफ रेफरेंस में जो अजम्पशन है कि जिस लोकेलिटी का डेटा हम प्रोसेस कर रहे हैं उससे ज्यादा डेटा आएगा, वो समझा नहीं।
इसमें दो चीजें हैं बेसिकली। एक बात तो ये है कि आप जिस डेटा को यूज कर रहे हैं उसकी बार बार जरूरत पड़ती है, ये तो एक सिंपल बात है। और दूसरा ये होता है कि मेमोरी में जब आप डेटा स्टोर करते हैं तो वो डेटा जो एक पर्टिकुलर चीज से रिलेटेड डेटा होता है उसको आसपास स्टोर करते हैं। तो इसलिए जब तक वो एग्जीक्यूशन चल रहा होगा तब तक ये माना जाता है कि उसके आसपास के डेटा की जरूरत पड़ेगी। ठीक है,
उसके आसपास की डेटा की जरूरत
पड़ सकती है।
तो
आप
वो पूरा ब्लॉक हम लोग
आते हैं
कैश
जिस
में
ब्लॉक का
इंपोर्ट
डेटा
कर
आप
देते हैं।
हैं?
जो पूरा जो भी रिलेटेड डेटा है सब कुछ हम कैश में इंपोर्ट कर देते हैं।
उसके अलग अलग एल्गोरिथम्स हैं, वो हम लोग जब कैश के बारे में बात करेंगे, और हम कैश के बारे में बहुत डिटेल में बात करेंगे, तो हम उसके बारे में डिटेल में बात करेंगे कि कैसे लाते हैं, कितना लाते हैं, कैसे उसकी एफिशिएंसी बढ़ाई जा सकती है। इन सब बारे में हम बात करने ही वाले हैं, बिकॉज दिस चैप्टर इज इंट्रोडक्टरी चैप्टर। तो अभी इसके बारे में बहुत ज्यादा बात करने का मतलब नहीं। डज इट मेक सेंस? हाँ,
yes sir.
Does this answer your question partially? Shivam is writing something on that. Hey Shivam, what are you writing? Just tell me. Okay. So if there are no more questions, we'll stop here. And in the next class, we will be discussing more, right?
Sir, please make the Google Classroom.
Yeah, I'll make that. Anything else? Anything else? No. Okay.
No, so we can end.